Okay, so this problem will be very similar to the one we had already done. So if you want to give this one a shot, give it a shot. You'll see how I laid it out was I gave you space to draw your tree and then asked you a couple questions regarding your problem. Okay, so if you want to, give it a shot. Otherwise, here we go. Um, First things first, we remember from our tree, I'm going to want to find something where there's no conditional probability. I'm just going to want to find just a stated probability. So let's see what we can find. Um, there used to be a phenomenon of people borrowing music and movies from the internet. I don't know how they do this. I actually wrote this. I don't know how they do this, how this was done, but from what I heard, you could download files from other people's computers. Now, I know there's nobody out there who would do that because I do not believe that that is very legal, but I've heard of this phenomenon. And businesses wanted to know if it was actually hurting their bottom line. So what they would want to know is looking at the people who are decreasing their spending in music and in movies and that kind of stuff. Were they the people who were downloading, or was it more the issue of people who was their market share decreasing? Were people spending less money for other reasons? And so this question is based off of that concept. So here we go. Some statistics gathered found that 15% of 18 to 29 year olds who use the internet decreased their spending on music and movies. The data also showed that 80% of 18 to 29-year-olds who were not who were non-internet users had not decreased their spending. Now, there's a key difference here. We're going to highlight this because here, these are people who decreased their spending. These are people who did not decrease their spending. So watch for that. Um, According to Bing.com, 80% of 18 to 29-year-olds have internet access in their home. Okay, so I think that's it. I think we just found our key statistic right here, our non-conditional. Just 18 to 29-year-olds that have internet at home, it's 80%. So the first piece of our tree is, do you have internet or do you not have internet? And Bing told us 80% do, which therefore means 20% don't. Okay, now the next key piece of this was the decreasing or not decreasing spending. Okay, so did they decrease spending or did they not decrease spending given that they have internet? Or did they decrease, not decrease, given that they don't have internet? So this seems like our tree. So let's see if we have these to fill in here. All right, so going back to the yellow highlights, some statistics gathered from 15% of 18 to 29, whatever, found that use the so the ones who use the internet decrease their spending on music and movies. Oh, 15% decreased. All right, so there's a 0.15 decrease, which therefore means 0.85 did not decrease their spending. Okay. The data also showed that 80% who were non-internet users did not decrease their spending. So there we go. So therefore, if 80% did not decrease their spending, that means 20% did. Great, we've got a tree. Now let's hear what questions are being asked. What is the probability that an 18 to 29-year-old, I cannot say that, 18 to 29-year-old who decreased their spending on music and movies has internet in their home? So what is the question? What is the condition? What do we know, and what are we asking? Right. So, and when I read this here, what I'm seeing is we know it's the statement is what is the probability that an 18 to 29-year-old who decreased their spending, we know they decreased their spending, it is a given, they decreased their spending on music and movies, has internet in their home. So therefore the question is do they have internet? Hey, this is the exact same as the ones before, just new context but the same idea, right? Given that they have internet, what is the likelihood they decrease their spending? So therefore, going through our tree, we're going to go to the decreased spending leaves, and therefore my denominator will be both of those branches, zero point 0.2 times 0.2 plus 0.8 times 0.15. That's my whole denominator. because that is my total possible branches that lead me to decreasing in spending. The question is do they have internet? Well, so that branch is the 0.8 times 0.15. And there's that question. All right, the other one is if you know the 18 to 29-year-old has internet in their home. Okay, so now this one is saying we know they have internet. It is. What is the probability given that they have internet? What is the probability that they didn't decrease their spending? Okay, so probability of not decreasing spending. I like to call these problems duh. Okay, and the reason why is we already know the answer without doing any work. We know that they have internet, so therefore we're already standing somewhere partially into our tree. We're standing at the internet node, and now we're just looking and saying, all right, we know they have internet, so what's the likelihood they didn't decrease their spending? Well, that was given to us in the problem. That's 0.85, and you'll notice this, the way it's written, matches what's written in the tree exactly. So if you use your correct notation in the tree, it just kind of jumps out at you. Okay, now I'm going to pause the video and get this number because I want to talk about what the actual calculation is. So you can do the same thing if you would like. So what I found is my numerator was 0.12. My denominator, when I did 0.2 times 0.2 plus, again, the 0.12, which gave me 0.16. So therefore, those numbers divided gave me 0.75. So that means, what does that mean? What does that mean? Given that the person decreased their spending, there's a 75% chance that they have internet access. Now, is that definitive? Does that tell me that these are people who are stealing music? No, not necessarily. But what could we do to kind of seek a comparison? Well, why don't we do a separate problem? Why don't we do another problem where we say, what is the probability of a person that decreased their spending that they don't have internet access? Well, how does that change the problem? Well, right, isn't it the same tree? Just the same D, except now instead of asking the question, the desired branch, instead of going through the I, would be through the I prime, right? So therefore, the only thing that's going to change in the problem is the numerator, right? The denominator will still stay 0.2 times 0.2 plus 0.8 times 0.15. And then my numerator is now going to just become 0.2 times 0.2. And logic will tell you, hey, that's going to be, well, careful on logic. Actually, we're going to be careful on logic. What would that come out to be? Calculate that out. My denominator is still going to be the same. That's still going to be 0.16. My numerator is going to be 2 times 2 is 4, right? But 2 decimals, so it's 0.04. So yes, that is the remainder of the 75%, giving me 25%. So if 25% of your customers are decreasing their spending, and they're not the ones stealing the music, is that a sign of a bigger problem? And this is data. This is stuff to help you analyze and determine your market share and how it's changing. Okay, and I'll leave that to your business courses because I am a mathematician. I am not a businessman, so I'll leave that up to you guys. Okay, last problem. Now, this problem is about the University of California, Los Angeles. They are notoriously difficult to get into. And their acronym, their abbreviation is UCLA. So when accepting students, there are 3 types of students that how they kind of break them up. There are in-state, there is out-of-state students, and then there are foreign or international students. UCLA accepts, they try to accept, from what I've been told, they try to accept about equal amounts from the groups, just depending on how many applicants and whatnot. But they always try to keep it proportional. Okay, now that could change over time, and so whatever, don't quote me on it. But here we go. So we know UCLA accepts about equal percentages of the groups. 23%, they accept 23% of their in-state applicants, 28% of their out-state applicants, and 22% of their foreign applicants. Of all the applicants, 80% were in-state, 10% were out of state, and the rest were foreign. So if we're making our tree, what is our non-conditional probability? What is the thing that is just how it breaks out? Here's how it breaks down. So let's see. The the way I see it here is just the applications are not conditional. And the reason why, you might be saying, I mean, you might be saying, I don't see any condition in the other part either. Well, when we get to there, let's see if you can then see it, or I'll explain it. So, of the applicants, 80% were in state. So, 80% were in state. 10%, I'm not going to use O for out of state because that would be confusing with a zero. So I'm just going to make it U for United States. So therefore, 10% were from the United States, and the rest were foreign. So that would be another 10%. All right, now, here's the condition. Given that they were in-state students, we know these are in-state students, what percentage of them were accepted? And that's where your condition comes from, because these are all broken out. The in-state is broken out right here. They accept about equal percentage from each group. 23% of the in-state applicants were accepted, right? So it's already broken out into its condition because they're breaking into little groups. So therefore, for our in-state, what do we have? 23% are accepted. So we'll do it A and not A prime. So therefore 23% accepted, which therefore means 77% not accepted. From the United States, the out-of-state applicants, again, 28% were accepted. Whoops, that's a U. And therefore, the other percentage of that would be, what, 72% were not accepted. And we're almost done here. For the foreign students, how many were accepted? What percentage? 22%. 22% right here. Okay, so therefore, for our foreign students, 22% were accepted, and therefore 78% were not. Now, the question. If you were on UCLA's campus, when you're just walking around the campus and you're looking at all the students, what is the probability that when you pick one random student out, that they would be from California? So, what is this saying here? What is the given? Well, the given, I didn't explicitly say it, but there's the idea that you have to kind of pick up on that, that they were accepted. They would not be on the campus. If we were picking out from the students, they would not be on the campus if they weren't accepted to the college. So therefore, it's given. We know they were accepted. So therefore, the question is what is the probability that they are from in-state? What is the likelihood they are from California? And this is where there was actually a big lawsuit in the past because they said UCLA was accepting students they weren't accepting enough of them from California. They were taking from other places to generate higher revenues and all sorts of fun stuff. So this was the game that you could then play. And you would say, okay, here we go. I have a guarantee. I know that the student is accepted. So therefore, I'm going to put a star next to every accepted branch. And just to clean it up, anything that was not accepted, any student branch that's not accepted, I'm going to kill it. You're dead to me. This branch is dead to me. Okay, so now you'll see I actually have 3 branches. Okay, doesn't change anything. So we still say do the exact same process. 0.8 times 0.23, that's one of my possible branches to get me to accepted students. Or 0.1 times 0.28, that's another branch that gets me to accepted students. Or 0.1 times 0.22, that's my final branch, right, for the foreign students, the international students. Okay, now, which one of these takes me through the question? Which one of these branches, or it could be multiple branches, but in this case it's just one, which one takes me through I? Well, that would be the California students, right? That's the in-state. So therefore, my numerator is just going to be the 0.8 times 0.23. And you might be saying, wow, there's 3 branches, so it's probably, it's going to be really small. Well, pause the video, do the math. I'm going to pause the video, do the math, and let's see what we get. So what I came up with here was the numerator was 0.184 and the denominator was 0.234. And so what that's saying is yes, the likelihood of you getting accepted isn't good. Given you're a California resident, going down that branch, 0.184, yeah, not great. But UCLA is very competitive. When you look at it from the total probability of 78.63247%, on that campus, almost 79% of the students are California residents. Now, is that enough? That's a different discussion. You can have that discussion all you want. But the reason it seems deceiving when they say that they accept about the same proportions from foreign, out of state, and California residents, it's disproportionate and it's a little misleading because of the number of applicants. They receive so many more applicants from California than they do other places that if they accept the same rate, 23% of their applicants get accepted, they're going to have a lot more from people from California than from other places. Um, so take it for what it's worth. Um, that is a completely made up story. I totally got you, April Fools. Okay. Anyway, this was when I was recording it, but nonetheless, I had you going, didn't I? But anyway, these numbers, the argument actually is real. That these numbers were proportionate to one of their school years that I found online. I have no idea if they actually try to take the proportionate amounts or whatever, but enjoy the argument. All right, so I hope Bayes' theorem doesn't keep you up at night. Just remember, draw your trees. Don't try to memorize formulas, because the second we start adding in more branches, those formulas go out the window. But if you could draw the trees and kind of make stars by your knowns, then you'll never go wrong, and you'll be able to get through any problem they can ever throw at you. All right, we'll see you in the next video.